Before the first tree rooted itself into soil, before the first shark cut through shallow water, before the rings of Saturn had finished forming around a young gas giant, something was already drifting through Earth's oceans. Not a primitive sketch of life waiting to be refined. A fully realized predator, pulsing, hunting, silent. Jellyfish have been here for more than 500 million years, and the number only grows stranger the longer you hold it. The dinosaurs rose and vanished in roughly 165 million years. Jellyfish have been drifting for more than 3 times that span. They have no brain to plan with, no heart to fail, no bones to break, no blood to spill. And yet something about that near-nothingness has made them almost impossible to kill. Every mass extinction in Earth's history has ended a chapter for nearly everything alive. For jellyfish, each one was barely a pause. What you are looking at is not a simple animal. It is a solution, arrived at so early and so completely that 500 million years of catastrophe has found almost nothing to improve upon. The question that haunts every paleontologist who studies them is not how they survived. It is what, exactly, they are. Because the more closely science looks at these animals, the less they resemble anything we understand about life's rules. A nervous system distributed across the entire body with no center. Senses without a brain to interpret them. Predation without pursuit. They are not waiting to become something more complex. They never needed to. And that, more than any fossil or extinction boundary, is what makes them genuinely strange. But to understand how strange, you have to go back to the record they almost never left. Welcome to Fathomless, the animal that was already ancient when dinosaurs were born. The fossil record of jellyfish is one of the most frustrating puzzles in all of paleontology. A creature that is roughly 95% water, with no mineralized shell, no teeth, no skeleton of any kind, should vanish the moment it dies, and almost always does. What survives instead are impressions, faint circular ghosts pressed into fine-grained sediment, the outline of a bell caught in the precise moment between death and dissolution. To find one is to find evidence of a catastrophe. Rapid burial, low oxygen, almost no scavengers, that preserved in stone what should have dissolved in hours. Sites like the Burgess Shale in what is now Canada have yielded some of the earliest soft tissue preservation on Earth. Among those ghost impressions are animals paleontologists now classify as medusozoans, the lineage that includes all true jellyfish. Some of these Cambrian forms drifted through seas so alien in chemistry and oxygen content that most modern marine life could not survive in them. And through that primordial water, something recognizably jellyfish-shaped was already pulsing. The jellyfish that left no trace behind almost certainly outnumbered these survivors by millions to one. The fossil record is not the history of jellyfish. It is the rarest possible glimpse of it. What makes these fossils so precious is not just their age, it is that they exist at all. Soft tissue preservation of this quality requires a very specific catastrophe: rapid burial, low oxygen, almost no scavengers. The conditions had to be exactly wrong for everything else, and exactly right for the ghost of a bell to survive in stone. And what those glimpses reveal is that even in the Cambrian, these animals were not experimenting. They had already arrived at a design they would keep. Not a draft, not a prototype. The finished thing, already complete, already drifting, already ancient in a world that had barely begun, That finished design was not tested once. It was tested 5 times, and 5 times it held. The end Ordovician glaciation, the late Devonian collapse, the Permian extinction, which killed an estimated 9 in 10 marine species, the Triassic boundary event, and finally, the asteroid impact at the end of the Cretaceous. Each one restructured the ocean from the chemistry up. Temperature, oxygen, food web architecture, all of it shifted, sometimes within windows so short they barely register in the rock. The animals that died were, in most cases, specialists, tuned to specific prey, specific temperatures, specific ecological slots that simply ceased to exist. Jellyfish are almost the opposite of specialized. They feed on whatever drifts within reach, fish larvae, zooplankton, soft-bodied invertebrates. They tolerate oxygen concentrations and temperature ranges that would be lethal to more complex animals. When the ocean destabilizes, they do not need it to stabilize again. When the Permian Ocean's chemistry collapsed, the calcified shell builders, the animals whose entire architecture depended on a stable supply of calcium carbonate, died in vast numbers. Coral reefs, which had taken hundreds of millions of years to build, vanished. Jellyfish, needing no mineral to construct themselves, no reef to shelter in, no specific chemistry to maintain a skeleton they did not have, kept drifting. There is evidence from multiple extinction boundaries that gelatinous zooplankton, the broader group that includes jellyfish, not only survived these events, but may have bloomed in their aftermath, expanding into the ecological space left by everything that died. The ocean, stripped of its most complex inhabitants, became briefly simpler, and in a simpler ocean, the simplest successful architecture wins. Surviving a mass extinction is not about being the strongest animal in the ocean. It is about needing the least from an ocean that has stopped giving. What followed each extinction boundary was not a vacuum. Vacuums in ecology are filled, and in the aftermath of catastrophe, the organisms that fill them fastest are those that need the least infrastructure to expand. Gelatinous zooplankton, already present, already tolerant, already feeding on whatever remained, spread into the open water. The blooms that followed these events were not anomalies. They were the ocean doing the only thing it could with what survived. This pattern, collapse, followed by gelatinous expansion, appears to be a recurring feature of the fossil and geochemical record at extinction boundaries, not a single isolated event. 5 times the ocean was restructured. 5 times something boneless and brainless was there on the other side. And each time, the world that eventually recovered was one in which jellyfish were still present, still pulsing, still unchanged. Not because they conquered anything, because they never needed to. There is one species alive today that takes jellyfish biology somewhere that still has no fully settled scientific explanation. Turritopsis dohrnii, a few millimeters across, found in warm ocean waters, does not die in the way other animals die. Under stress, starvation, physical damage, the simple accumulation of age, its cells undergo a process called transdifferentiation. Mature, specialized cells revert to an earlier developmental state. The animal collapses back into a cyst, then regrows from the beginning as a juvenile polyp. The entire life cycle runs in reverse. This has been observed repeatedly in laboratory conditions and is considered by researchers to be a genuine biological phenomenon. What it means at population scale in the wild remains an open question. Ocean currents, predation, and disease all complicate any claim of true immortality in practice. But The mechanism is real. A multicellular animal that can, under the right conditions, biologically undo its own aging. The clock does not stop. It runs backward. Here, the full weight of everything in this story lands at once. A lineage that needed no skeleton survived because it left nothing for extinction to grip. A body plan so minimal it barely registers as an animal has persisted through 5 planetary catastrophes. And somewhere inside that ancient brainless architecture is a cellular mechanism that reverses time itself. Jellyfish are not a primitive leftover. They are not simple. They are the outcome of more than 500 million years of pressure testing against everything Earth could produce. And they passed every test. The oceans are warming now, destabilizing in ways that echo, faintly, the geochemical signatures at those extinction boundaries. In those conditions, jellyfish blooms are already expanding. Whatever comes next for this planet, something boneless and brainless and older than every tree that has ever grown, will still be drifting through the dark, pulsing, patient, indifferent, long after the last of us is gone. Thanks for watching. Subscribe for more.